We're here with lesson 4.4 on similar figures and proportions. So, first of all, similar means that they have the same shape and they might be different sizes. And this is the symbol we use to show similar. So they have to have the same shape, but they can be the same or different sizes. Congruent angles, congruent always means same or equal, but here we're talking about congruent angles. They have to have equal measures. And this is the symbol for congruent. I've also seen it written like that, just with one line under it, but your book right now is doing an equal sign with a similar sign above it. So those both lead us into similar polygons. Similar polygons have corresponding angles that are congruent and their lengths are proportional. Okay, let's look at an example. Example A. Is rectangle LMNO similar to rectangle HIJK? Now, it's important to pay attention to the order that they say these letters in, because in theory that means that L, the measure of angle L, should be congruent to the measure of angle H, M should be congruent to I, N should be congruent to J, and O should be congruent to K. This is especially important when we get to triangles or trapezoids or other figures that aren't a rectangle where all the angles are the same. So we have two questions to figure out. First is, are all of the angles congruent? And the answer to that one is yes, right? So we know that. Our second test is, are the side lengths proportional? And so we're going to use a proportion to figure that out. Remember what I said before about how we have to make sure that everything in the same row is related in a way and everything in the same column is related in the same way. So what I'm going to do is I'm going to pick one triangle or one shape, and I'm going to put all the information from that one shape in the same column. So I'm going to label it up here as big rectangle and this one as small rectangle. So let's take the numbers we've got from our big rectangle. We've got 10 and we've got 4. Now let's go to the small rectangle. So now the important thing is that I take both of these have a number from the same rectangle, and that whatever one I put here is the corresponding length to what went here, because anything in the same row has to be related to each other too. So since I took from the longer top side of the rectangle here, I need to take this number to go here, which is a 8. And then here I have my 4, so the corresponding length to that 4 in the small rectangle would be a 3. And now I'm going to test this just like I did with the last lesson. I can use any strategy I want, but I'm going to do 10 times 3 divided by 8, and I got 3.75. So is 3.75 the same as 4? No, it is not. And therefore, these two rectangles are not congruent. So my answer would be no, because they have congruent angles, but not similar sides. And we're talking about the lengths. All right, you can use proportions to find unknown lengths in similar figures. This is only true if they tell you that the figure is similar. So here's our example. Triangle ABC, which also means that the side length AB is corresponding to DE, by the way. But triangle ABC is similar to triangle DEC. Find X, which is right here. I'm going to use a proportion. Okay, same thing. I'm going to do the big triangle here and the little triangle here. So for my big triangle, I always need to make sure that too, I'm looking for some sides that one of them relates to the x and one of them that they both have labeled. So right now they're only labeling some of them. That makes that easy for me. So I'm going to take, let's start with our little triangle since that's where our x is. Okay, so I'm going to take 16 and I'm going to take x. And it doesn't matter if I do it on the top or the bottom or where I put them. I'm going to put 16 there and I'm going to put x there. Now I'm going to pick two numbers from the bigger triangle, but they have to correspond. So side EC corresponds with side BC. So I know this is 8 and I know this is 16. To find the total length, I have to add those together. So I'm going to do 16 plus 8, which is 24. And so I'm going to put the 24, and I have to figure out, is the 24 the same side as the x, or is the 24 the same side as the 16? Good, it's going to go up here with the 16, because they're both the bottoms of their triangles. And now this one, 18, corresponds with x. Now to solve, I'm going to do 16 times 18 divided by 24. And so x equals 12 feet. Let's look at how to do this with cross products and an equation too. So that way if you want to ever use that, you can. So the other way that I can do it after I have my proportion set up, I can say that 24 times x equals 18 times 16. And then to solve this equation, I would say, well, 24x equals, and 18 times 16 is 288. And then from there, to get x by itself, I'm going to divide by 24, and I'm going to divide by 24, and I'm going to find that 288 divided by 24 equals 12. So I'm going to get to the right answer anyway. And actually, if you look at the steps I took, 18 times 16, and then I divided that number times 24, that's exactly what I did over here, 18 times 16 divided by 24. I just skipped writing it out as an equation. But you can do the equation if you would prefer to solve them that way. Here's just a reminder with proportions. The key to proportions is making sure the numbers in each row and column are related to each other in some way. So you're asking, what do they have in common? All right, you are designing a poster. A sketch for the letter H is shown. The letter will be 9 inches tall. What is the width on the poster? So I am going to say, and I can write it here or I can write it here, because it doesn't matter if we switch the order of how we're grouping, as long as what's on the same rows have something in common and what's in the same columns has something in common. So let's do this to be the letter, and this down here is going to be my poster. Okay, so I'm going to take the things from my letter first, and I have two different sides, right? I have the 5 and I have the 4 that both are from this letter. My 5 was my height, and my 4 was the width. I'm going to rewrite this the small letter so that way we don't get it confused. Okay, so now I know that the letter for the poster is going to be 9 inches tall. So it's tall, we're talking about the height of it, so which column is that going to go in? And so my unknown is my x, and so to solve, I'm going to do 9 times 4 divided by 5, which equals 7.2 inches. So the width of the poster would be 7.2 inches. Now I could have switched that, and I could have lined it up so that way the 5 and the 4 were in the same column, and as long as I kept looking for what's equal, it would have worked out just fine. All right, here's another example. John is 6.3 feet tall and his shadow is 4.2 feet long. So John, we got 6.3 tall and his shadow is 4.2 feet long. That's how tall he is, that's his shadow. And this has all to do with John, if we want to label the top two. Now let's look at our second one. A tree's shadow, so this is talking about the tree. A tree's shadow is 13 feet long. So will that go on the top or will it go on the bottom? And we have to solve for the height of the tree. So I'm going to do 6.3 times 13. And then I'm going to divide by 4.2. And I get that the tree is 19.5 feet tall. All right, I think that you are ready, so go ahead and get to work.